Hi everyone, thank you very much for coming. I'm Dr. Melinda Barkezen for MagneFeCent. Imagine if you only had one more year to live. For most glioblastoma patients, this is a reality. So at MagneFeCent, we are trying to unlock the power of magnets to change this. Neuroblastoma is a cancer of the brain. It affects a part of us that makes us us. And as such, it has a tremendous impact on the quality of life. Here we have 3 different patients that were living full active lives before they got the devastating diagnosis of glioblastoma. And although they had tumors in different parts of the brain, which led to a whole variety of different symptoms, they all got the same standard treatment of surgery followed by radiotherapy and chemotherapy with temozolomide. Unfortunately, these therapies don't work very well. It is very difficult to treat glioblastoma because it is really difficult to get enough drugs through the blood-brain barrier and to the tumor. So at MagneFeCent, we are developing the GlioMag, which, to put it simply, is a very strong magnet, as strong as a big commercial MRI scanner that we can pack into a small helmet that we can personalize for each patient. And we want to use our magnet to pull drugs through the blood-brain barrier and to the tumor. So we tried this in mice. We used the GlioMag to improve the efficiency of temozolomide. And what we saw is that if we treat humanized mice with a human glioblastoma with standard temozolomide, only 20% of them were still alive after 50 days. But 100% of our GlioMag enhanced temozolomide treated mice were still alive at this time point. So we were very, very excited about the data. We have already filed a patent and we've completed the mice proof of concept and we have built a rough prototype. So now we are raising our seed funding to do a proof of concept study in pigs because their brain physiology is much closer to the human physiology. So that will give us a really good idea on how well this works in something with a human-sized head. And we also need to refine our prototype a bit into a clinical unit so that we can start clinical trials and hopefully have this on shelves by 2027. The glioblastoma market is the place to be. It's very active, it's growing, it's predicted to reach $3 billion by 2026, and at the moment there are more than 450 active and planned clinical trials. So what sets us apart in this market is that we are packaging the strength and the precision of a big MRI scanner that they use in hospitals into a small, low-cost device. But our device is much more accurate than if you would just take a simple magnet off the shelf. So basically, there are 2 types of magnetic fields. Permanent magnetic fields, which can be used to draw magnetic nanoparticles to a specific spot, like the one we're using, and that's used for targeted drug delivery. And then there's also alternating magnetic fields, which makes magnets vibrate in one specific spot, and that generates heat. The heat-generating nanoparticles are already on the market for glioblastoma, but so far they haven't done very well. And that also requires a very big piece of machine to lie in. So we think that using a small portable targeting device really fills an important gap in this market. So when we see the future, we see a future where every doctor that has a glioblastoma patient has one of our devices right there in his room, because the small portable nature of our device makes it really suitable for use in outpatient settings. We are developing GlioMag enhanced temozolomide on our own, but our platform can be used to deliver any drug to any difficult to reach body part. So we are also looking for opportunities to sub-license our technology. We have an excellent team of biomedical scientists and MBA level business professionals. And importantly, the inventor of this technology, Dr. Muthana, is also on our team. And we need $1.5 million in seed funding to complete our next proof of concept study and to develop our clinical prototype. And we're also looking for partnerships. So if you can manufacture magnets on a large scale, or if you have a drug that can really benefit from our targeting approach, please get in touch with us at the details below, because together we can create a future without glioblastoma.
Thank you, Melinda. Great, excellent presentation. Does anyone have any questions for Melinda? Any questions?
Yeah, I've got one. Maybe I missed it. Sorry. Um, uh, how does this work? In other words, do you have to couple a something magnetic or iron or something to the drug and let it be pulled, or is it naturally susceptible to magnetic forces? I'm curious about that. Maybe you,
We use iron oxide nanoparticles that are
okay,
already
gotcha.
approved for the other types of magnetic fields. And we
Okay,
encapsulate the temozolomide with that.
gotcha. Thank you.